Testing, testing. Okay, hello and welcome back. Today I'm playing a little bit of Human Resource Machine. Let's see what progress we can make. Yes, please select your employee ID. I'm the employee number 2. Small divide. Year 26. Remember last time when I told you didn't need to divide? Well, now you get to. For each two things in the inbox, how many times does the second fully fit into the first? Don't worry about negative numbers, divide by 0 or remainders. Self-improvement tip. This might be a good time to practice copying and pasting from previous assignment. Oh! Didn't know that was possible. Never mind. Let's for once use 1, 3 and 5. So, grab a number from the inbox. How many times does the second fully fit into the first? Okay. Get from inbox. Copy to spot 1. Grab the second number from the inbox. Copy to spot 3. Then we can just walk up and down here. Then we have the numbers. Then we need to see. Okay. Let's do this. We have the numbers. Let's copy from number 1. Let's subtract number 3. Well, this is... yeah, let's ignore that. Let's ignore the labels. We don't need them. And if that works, if negative, copy from box 5 and go to the outbox. So we don't have number 5 set up, which is what we should do as well when starting everything. So let's copy from number 9, copy to number 5. There we have number 5 set up. So this is how many times divides. So, okay, we grab from 1. Actually, let's put the label here. Oh shit. That was bad, but never mind. So all of this is set up. This is the output. What? Copy from 5 and then outbox, of course. That logic is copy from 1, subtract 3. If it's negative, that means we have gotten too far. Then we want to grab what's in 5. If it's not, we want to jump plus number 5. And we want to jump back to start the logic. I think this will work. So, number 6, let's put 0 in place. Grab that. Oh, no, this will not work. This is an infinite loop. I forgot one thing. If I subtract 3 and it's not negative, then we want to copy it back to number 1. And then it should work. So 8. Let's set up the 0. Set up the 2. Okay, 8. 2, that means it's 1 time. 6, 2 means second time. That's 2. It's third time. 2 minus 2 is 0. Means if it's fourth time. Now it's negative. Then let's grab number 5, put it to the outbox. And I think that should work all the way through. But let's see. We probably need to... oh! We got the size challenge right away. And the speed challenge. I was just about to say we probably needed to optimize it a bit. But not even that. That's really nice. 3 sort. Yes, we rank all our employees here. From worst performing all the way to best performing. What? Where do you rank? Let's give it some thought while we complete this assignment. Well, I have been here for long and I'm still here, so I can't be your worst employment at least. For each 3 things in the inbox, send them to the outbox in order from smallest to largest. And I have already set up to place numbers in the boxes. Let's do this, just to get everything. Get everything set up with a loop. Send them to the outbox in order from smallest to largest. Okay. The thing is, this wouldn't be especially hard with only 2 numbers. But how can I see what number is smallest from 3 numbers? I think I need to do it combination by combination. Or at least that's a possibility. So let's set up, this is logic. So let's copy from 1. Actually, no. We already have the number 2 digit. So we have that. Let's subtract the number 1 digit and see the number we get. Oh, if that minus that is... Nah, let's do it the easy way. I just can't get my head around this. Actually, let's do this instead. Instead of thinking about 0, 1, 2, let's think about A, B, and C. That makes a big difference. A, B, and C. So, if C minus... yeah, minus 8, that's fine. So, if 5 minus 1, that is negative. That means that A is big. Wait, was that C minus A, 5 minus 1? Okay, 1 minus 5, so if it's negative, it means A is big. then we know A is bigger than C. Where does that lead us, really? Ooh. I mean, we can work with it. It's not that. But oh. I have an idea. Have an idea. Let's ignore that. Ignore that. Let's ignore that. Instead of comparing and trying to figure out which way it should go, let's put them in the bottom row. And when we do, let's put them in order, if we can. Or rather, let's change... Do we need to put them in the bottom row? I don't think so, actually. Let's do this. Have a temp variable here. Okay, C minus B. If C minus B, that is negative. I don't know what I want, actually. That's a good question. What do I want? In this case, it will be C, which is 3, minus B, which is 4. 3 minus 4 will be negative. For some reason, I can't get my head around this. It's not... I know what I need to do. I just can't get my head around which one is smaller and bigger. So, with this numbers 8, 4, 3, just made a note with this to see how they are placed right now. So, if 3 minus 4 is negative, I think I want small, big, big. And how can I do that with 3 numbers? I need to be able to move C to A and A to C. How many swaps do I need to handle? 1, 2, 3. Do I need to handle more than 3 swaps for that? Yes, I think I need 4 swaps. But by swapping those 2, then those 2, then those 2, then those 2, it should be possible. Okay. So if C minus B is negative, we do nothing. Ah, yeah, that's a way to do it. If C minus B is negative, we do nothing. If it's positive, we want to swap C and B. And that means... copy from C, copy to temp, copy from B, copy to C, copy from temp, copy to B. So that's one swap. Oh yeah, now we already have this that we want to test against A. So basically we want to do all of this again, but between B and A. So let's say sub that from A, negative, we do nothing. And by always starting from the right and going to the left, or from the left and going to the right, doesn't really matter. We make sure that we don't need to worry actually if it's negative or positive, more than grabbing them and putting them into the outbox. So if it's negative, we copy from B, copy to them, copy from A, copy to B, copy from them, and copy to A. So now if, let's see, if C is on the edge, it have been moved there and there, or it have been kept. It have been moved there and there. If we just change B and C again, then we should have everyone in order. So let's just do that. Copy from C. This time we don't have the C already, that's why we need to copy from. Subtract B, negative, we do nothing. Actually, we will jump up. No, we won't. We need to go to the outbox. Never mind. But if it's negative, we have to do all of this again. Copy from C, copy to... No, we don't. This is special, isn't it? No, since it's not necessary we get into this loop, we need to do it no matter what. What I was thinking is that maybe we could grab and use one of the numbers and put it to the outbox directly, but we can't. We don't know which one is smaller. Or we don't know if we hold any of those or not. So copy from C, copy to temp, copy from B, copy to C, copy from temp, copy to B. Actually, this will work. This will definitely work. Let's run it. I know that I don't have any outbox yet. Let's run it anyway, to see which way they actually will go and if it works. Oh. Stop. So this was a problem. This sub A, it only works if we are in the negative loop. So we need to copy from B over here. We might have it from here, but we might not if we get up here. Okay, so what we found out is that C is the smallest. So copy from C, the outbox, copy from B, the outbox, and copy from A and go to the outbox. So let's see what happens. Let's compare those. No. Compare those. No, we don't want to switch. Compare those. We don't want to switch. 1, 4, and 8. And this should work all the way through, but it's definitely not optimized. I mean, if nothing else, this last loop, we could put things directly into the outbox. Yeah, 39 commands, that's not big. Oh! And a lot more steps than we need to. Let's look at the size first. There's a lot of work, size-wise. There's a lot of rows to check this, there's a lot of rows to check this, and there's a lot of rows to check this. Is it possible to move them somewhere else, check, and then move back? That way we only need this once. We need to move them down. But we don't have like a go-to command or something like that. If we could return to the same part of the code again, this would be way easier. I don't see that happening. Let's see what happens if we change these until change these to basically this. Not really those, but almost. So instead of switching all of those, let's say we copy from, we know that these two should switch place. Copy from B and go to output. Copy from C and go to output. And then let's get rid of the rest, please. We don't need to first sort them and then copy to the output. And then make a jump down here, so we get A, and we get the A from the same code no matter what. That should lower the code a little bit. I have a feeling that I have missed something in the code, not functionality-wise. But I shouldn't order the existing list, I should build new stuff. Instead of switching those, which is 6 steps, What if I just move them? There and there, or there and there. That would be read, move, read, move. Copy from, copy to, copy from, copy to, copy from, copy to, copy from, copy to, and jump. Well, 2 jumps. That's way more code. This seems fair. Since I would need to do it twice. Okay. Let's not worry about the number of rows now. Let's worry about the what's it called? The number of steps. And by not switching anything, by not moving anything around, we can lower the amount of steps. So what does that mean? Currently, okay, this is it. If negative, let's label these. If negative, don't know how to label them. So we do this check. If C is lower than B, then we know that, and then we have planned that inside here. So copy from B sub A. Jump if negative. If let's see. If well, still C is if C is smaller than B and B is smaller than A, then we have our result. So in that case, we want to copy from C outbox, copy from B outbox, and copy from A to outbox. And we can jump to the start. That's if all of them are in order. If those are in order, but those have to switch, which is the case now. Actually, let's get rid of all of this. If those are in order and those need to switch, we are not switching them, but we need to, after they have been switched virtually, we need to check. Well, after that, we don't know which one is smaller. A might be smaller than C. So copy from C, subtract A, does this lead to? If C is smaller than A, we know that, okay, copy from C, copy from A, and copy from B. And of course go to the outbox in between. That's what... Wait. Oh yeah, that's what's happening if those are in the right order, those are not. Then we check those, and if they are in the right order, we copy C, A, B. If they are not, oh, and then we return. Where do we have? Jump to the beginning. If those are not in the right order, we know that it's A, B, C. So copy A, copy from B, copy from C, and then go to the outbox. This is horrible code. Okay. So now we have handled all the steps. 1, 2, if those are in the right order. Those are not. Oh, we need to jump to the start as well. If they are not in the right order, we basically need to check C against A. So copy from C, subtract A, and if they are C is smaller than A. Is this correct, or is it copy from A sub C? We know this is larger than that. No, it's copy from B. Check C. That's it. Wait. Here we have C, A. Here we have B, A. Okay, so this is correct, I think. And then we have... I don't know what we have. That's the problem. Okay, so... Let's label it up. Why can't we have jump if positive instead? That would be way easier to think about. So, in this case, B is larger than C. Technically, can I say larger than or smaller than? It might be larger than or equal to. We don't make a difference here. So, get in here, B is larger than C, get in here. Oh yeah, we already have the B is larger than C. but we also have A is larger than B. Okay, okay. Now I'm getting it. And if we are not getting to that, then we know in this place B is still larger than C. But A is smaller than B. Yeah, this is it. A is smaller than B. B is the largest, basically, is what we're saying. So if we get here, from A sub A, then we know C is smaller than A, B is larger than A, is larger than C, I think. And here, yeah, here we know that. What do we know? What do we know? What do we know? We know for certain that B is larger than C. That follows all the way through until here. Let's just do a scribble there to know that this is where our logic stops, that B is larger than C. So if B minus A is negative, we know that A is larger than B. If B minus C is 0 positive, we know that A is smaller than B. Well, basically we know that B is the largest. So then if we take C minus A, and that is positive, then we know that C is smaller than A, which means A is larger than C, B, A, C, yeah. And if C minus A is negative, then we know it's B, C, A. B is larger than C, is larger than A. And that's not what we're doing. Okay, so somewhere we have a problem. CBA, CBA. This we can't get anything from. CAB, CAB. In this last case, we still know that B is larger than C. B is larger than C. And for some reason we had said that B is smaller than C over here, so this is clearly a problem with the outbox logic. So, if B is not larger than C, and we go down here, then clearly C is larger than B. So then we need to see that wasn't even intentional. Then we need to figure out, is C or A larger? Let's see. C minus B neg leads to B is larger than C. Just making notes. No. Yeah, leads to B is larger than C. Okay. So if C minus A, if negative, leads to B is larger than C, but A, oh, let's skip that. Let's see, C is larger than A, leads to A is bigger than C, which is bigger than B. Okay, so A is larger than C, which is larger than B. And that we can handle later on. If not, then we know that C is still larger than B, but A is smaller than C, right? You're comparing C and A one or the other way, yes. So in this case, we need to figure out which one of B and A is smaller. Copy from B. Subtract A. Okay. And if that is true, then B is smaller than A, which means C, A, B, maybe. So if B minus A is negative, then A is larger than B, yes. And we still have C is larger than B. And if this is positive, we still have C is larger than B, still have C is the largest, then it should be C, B, A. Oh, this is messy. This is really messy. Okay, so in this case, we need to copy from A, outbox, copy from... No. Copy from... Let's get rid of those. We need to have the smallest one first. So copy from B, the outbox, copy from C, the outbox, copy from A and to the outbox. In this case, we don't know, we make another check. In this case, we copy from B to the outbox, copy from A to the outbox, and we copy from C to the outbox. I just realized I haven't done any jumps. Let's do that last. Let's go through all of it. In this case, copy from A to the outbox, copy from B to the outbox, and copy from C to the outbox. And jump to the start. This is a lot of rows. This is definitely not fewest rows, but I think jump here. There we don't have anything. This is jumping, this is jumping. This should jump. We should have the least amount of commands needed in this case. No jump. Here we need to jump. We should have the least amount of commands, but definitely not the fewest rows. And jump 62 rows. That's way too much. But this is the thing. It will not run 62. Well, it runs several rounds. Let's see what happens. Copy to A, copy to B, copy to C. Use that. Let's check those. What? Yep, something went wrong. That's not surprising at all. C minus B. In this case will be 3 minus 4. And have I done all of the signs in the wrong way? Might very well be. That's clear. I have no idea what's happening with that code. Ah! Let's do another thing. A, B, C, D, E. Let's say that the first number we input is always C. Second number, which we subtract C. And if it's negative, copy to B, otherwise copy to B. And let's test run it. I don't know which way this will go. Oh That's B. Actually, this is what I want, but I forgot I had to add C again. So the thing is, I want to have lower, higher, 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 higher. If possible. Oh, wait. Stop and reset. That's Z. This is F. The reason for Z and F. The reason for Z is that A minus something. That's not possible. So let's go to the end of the alphabet. For F is that I want the first one in C, no matter what. I want the second one in A or E. Then we always know where we have numbers. And then the last one we want to place in Z, B, D or F, depending on where it fits. And then we can get all of them out in the same at the same time. But okay, sub C, if negative, we jump there, if positive, we go there, but we want to add C back in both cases. Add C, and not D. We want to copy it to E, not B. We want to copy it to A, not B. Let's test run it. 8 in the middle, 6. Let's check that. 6 is lower, so it should be an A. This is great. Now what we have to do... Okay. This is visual in a whole other way, actually. This is way better. Way better. Now we know that... what do we know? We know that we have an order between A, C, E. Okay. But let's see. If we place... This is smaller, so let's worry about this case first. We copy it to A. Let's copy from... No, not copy from. Let's grab from inbox. So now we have a new number. If we subtract A, let's see. Subtract C if jump if negative. And if that is negative, we know it is... we want to head back. A. And then we want to... Actually, we don't want to even place it. That's a waste of time. We know that this is the lowest. Let's just go to the outbox. Copy from A to the outbox. And copy from C to the outbox. And we have done the whole round. That should work. Let's see. Negative, so let's place that A. This one, let's see. No, that. Let's put it at the outbox. Let's grab the next number and the next number. Great. And then, of course, it will break in the next one because we haven't implemented that yet. Haven't added that code yet. So that is, we have A and C. We have A, we have C. And we know inside here that what we have currently, number we have is larger than A. Okay. Okay. So we want to add back A to get the original number again. We want to subtract C. And then we do the negative again. Negative. Let's see if something minus C is negative, it's before. Okay. If it's negative, let's add back C. Copy to B. And then we know that A, B, and C. Copy from A, the outbox, like that. Copy from B, the outbox. Copy from C to the outbox. Okay. So that should work as well, I think. But if this is if this is positive, then we don't want to copy to B, we want to copy to D. First add back C, copy to D, and then we want to read everything, copy from A, the outbox, copy from C, the outbox, and copy from D to the outbox. Okay. So what do we do in this case? Now we have a number at C and E. And we haven't grabbed the third number, so let's get inbox. Let's subtract C. I think this can be optimized. That's the thing. Let's subtract C, and then we have if negative. Oh, I forgot. Over here, we want to go to the start. Definitely want to go up to the start. And the same over here. So in all of these cases, we want to go back to the start after we have added 3 numbers to the outbox. Okay, what was I working with? Yeah, I was working here. So if inbox minus C is negative, we get into the same as here, that we want to output everything. So add C, put it in the outbox, copy from C, put it in the outbox, and copy from E and put it in the outbox. Okay. And then jump to the start, of course. So if it's positive, if the number we are holding is larger than C, we first want to add back C. Then we want to check it against E. subtract E. Negative. Negative what? If it's negative, we know that it's smaller than E. Then we want to think E, C. Yeah. Wait, what? Oh yeah. Then we want to place it to the left. Yes. Yes. So add back E. Copy to D. And then we get everything CDE to the outbox. From D to the outbox. And copy from E and put that here. And go back to the start. And in this case it's larger than E, it should be placed in F. So add E, copy to F, copy from C to the outbox, copy from E to the outbox, and copy from F to the outbox. And go back to start. 1, 2, 3, 4, 5, 6. I think we have the jump everywhere. Yep, it seems like. Let's see if this works. Let's speed it up just a little bit. That's smaller. Let's put 3, 4, 9. This 3 over there. 5 should be placed in E. 7 should be placed in F. Yes, and then C, E, F. Great. 1. It's the same. In E, that's fine. And paste over there. Those. 4 over there. This is smaller. This is larger. That's smaller. Yeah. Oh yes, I think we solved the steps now. But we definitely haven't solved the command size challenge. No, not even close. 7th? No! No! 1 step! 1 lousy step! Where could we remove 1 step? One single step. This is really annoying. I mean, technically we don't have to add E over here. We could do it after copy from F. But here or here, it's the same. And that's the same for all of the options. It is a bit annoying that we are adding everywhere. We are subtracting once and then adding twice, but for the amount of steps, it's not a problem. Or it shouldn't be, at least. You know what? Let's run this, let's be happy about it, and go to the next task. Yeah, we didn't get anything, but at least we completed the task. That's the important part. I'm not gonna worry about anything else. Zero terminated some. I might go back and fix it, but not now. Yes, we believe in educating our employees on the job here. Do you know what a zero terminated string is? Yes, it is a very old technique, and we don't expect you to know. So you may ask me about it if you like. Or you may ask an external source. Whatever helps you get the job done. The inbox is filled with zero terminated strings. What's that? Ask me, your boss. Add together all the numbers in each string. When you reach the end of a string marked by a zero, put your sum in the odd box. Reset and repeat for each string. What I'm thinking about is what happens if we get zero in the beginning. To start off, we have an inbox. We copy to number 0 or to position 0. And that's fine. And then we do a loop. And within this loop, we go to the inbox, check. If it's 0, we want to be from place 0, go to the outbox. Of course, we don't want to start there, we want to start with the inbox. If it's not 0, let's add to the 0 and copy to the 0 place. I think that should work. That should follow all the rules. Add those. Yes, that's a 0. Let's grab the number 0 place and put it in the outbox. Place there. Add those. Add those. And grab that. This is where I'm not sure. I think it should return a 0. Let's grab 0. Let's return setup. There we go. Yep, this works fine. What? Management expected 0, but you outboxed 5? What? Step back and debug. Want to see all of those numbers. Okay, so 6 minus 6 is 0. Plus 2 plus 4, that's 6. Minus 8 is minus 2. Plus 5 is 5. So it should output 5. Management is wrong. Yeah, management is definitely wrong on this one. Stop and reset. Let's run it again. Let's see, 8 plus 8 is 16, minus 2 is 14, minus 5 is 9, plus 3 is 12. Oh, now I know what's happening. Actually, they might be right in one way of interpreting this task. It will say they want 0 when they get 12. Exactly. The problem is with multiple zeros after each other. how I have handled that is to throw away the first 0, put the next one in the box, check the next one, and output. But if it's a 0 over here, we basically want to output 0, and we don't worry about anything else. If 0, let's jump here. If 0, the first number we get from the inbox, go to the outbox. And then jump to the top of inbox again. That should solve it. Let's have a look now. This should be 6. But now we should grab 0 and we should go to the outbox. Should grab another 0. We should go directly to the outbox. This is not what the task said, but this is what they want. That's management. We should cover all of it. And oh! Let's see if we can fix the size of that. Okay, now I see why we have this 0. If we use this 0, copy that to space 0 to start with, we don't need to have any checks. This one, and this one, and this one can be removed. So when we start before the inbox, before the inbox, copy from 5, copy to 0. Wait, get rid of that. When we start, copy from that, place a 0 there, then we read each number. Okay, yeah, that works. Actually, let's go full speed. That should solve the size of the program, but I think we will get a few more steps than we got before. Yeah, the size challenge is fine. The speed challenge, yeah, I didn't expect to solve that this time. This is annoying me. Let's go to the littlest number. Reduce our carbon footprint. Management is requesting the smallest numbers only. This is a public relations exercise. The results are going straight to the landfill. Yeah, that's good for carbon emissions, right? For each 0 terminated string in the inbox, send to the outbox the smallest number you've seen in that string. You will never be given an empty string. Reset and repeat for each string. What is a 0 terminated string? Ask your boss on the previous floor. That's actually fair enough. And this time we don't have a 0 to start from, which means that it's different rules than the previous rule. Inbox, copy to position 0. And what do we not do now? Now we want a loop, and in that loop we grab a number, we subtract we have, so we have 14 minus 7. 14 minus 7, that's positive. Don't want to do anything with positive numbers, so we just want to do the jump. But if it's negative, we want to do something with it. We want to add back the 0 number and and copy it to the 0 number to get the smallest. Oh, but I forgot the whole 0 terminate stuff. But okay, the first number we should jump to this. This we only want to do if we have a negative number, which means the new number is smaller. Wait, 7, 14 minus 7. 1 minus 14 is negative. Yes, exactly. So if this is smaller, we want to jump to that. But we can't forget the 0 termination thing. So the inbox, if that's 0, let's do it at the bottom for once, and then move it to the top when it's complaining that we use too many commands. If it's 0, copy from 0 to the outbox, and then jump to the top of everything. Okay. Check that. It's positive, let's throw it away. That's negative, which means the number is smaller. Let's go there. 0. Let's put that number in the outbox. Oh, now we get some larger numbers. But it doesn't really matter how big the numbers are. The same logic anyway. 13 commands. Oh, that worked. 75, 73. That's great. We succeeded with that one. Let's check the cumulative countdown. However that's pronounced. What is the purpose of this assignment? I think it's something about calculating the volumes beneath staircases. That's strange. Have to put the interns somewhere. But beneath the staircase? For each thing in the inbox, outbox the sum of itself plus all numbers down to 0. For example, if inbox is 6, outbox should be... if inbox is 3, outbox should be 6 because 3 plus 2 plus 1 is equals to 6. This is called the triangular number. So how do we do that? Grab the inbox, copy to place, and copy to 0 and 1. So 0 is the add, and 1 is the sum. And to start with, they're both the same. Thing. Yeah. Then in a loop, actually let's do the loop. In a loop, let's copy from add, check if it's 0, we want to add the sum to the outbox, sum to outbox, and jump to the beginning. If it's it's not 0. No. No. Not copy from add. Bump minus add. And not if 0. If negative. That saves us a few steps. So we take that -1. If it's not negative, we add it to the sum. We copy to the sum. And then we jump back here. I think that's it. Or oh, except that we should still keep if negative. Oh, if 0, I mean. Oh, we can't, because in this case, grab a 0, and then we need to handle that. That's a chroma case. We need to handle that specifically, either way we do it. 11 commands, that's okay. But yeah, we use quite a few more steps than necessary. And I think that have to do a lot with this, if negative. Let's see if 0 instead. Let's see what that gets us. I think it will be wrong with this. I think this will just add, decrease and add infinitely. Yeah. So, inbox. If that is 0, jump down to the outbox and jump back up. But then we have 2 jumps. Let's see what happens. Eight. That's a large number to do triangular numbers. We're still inside the size, and we got the speed challenge. Yeah, let's continue to elevator, and let's check out Midnight Petroleum. And I think that's gonna be the last thing I'm doing in this stream, but let's check it out. Oh yeah, we had aliens, robots, and something else. Ah, oh. It's kind of scary and fun at the same time. Ah, let's do one more. Storage floor. Oh, I think we're up to the really hard ones. Oh, big changes are coming. But I see you already know that. Yes, you can now access slots on the floor indirectly. What does that mean? You will see. It's going to change everything. Imagine each thing in the inbox is an address, and each address refers to a tile 0 to 9 on the floor. Your task: for each address in the inbox, pick up the letter at that address and outbox it. Congratulations, you can now access tiles on the floor indirectly. Otherwise, observe this example to see how it works compared to what you've been doing so far. Copy from 12, copy that, copy from this 12. Oh. Let's run the example and see what happens. Copy from 12 is there. Oh, okay. So this is not copy from 12, this is copy from the number that is in box 12. Okay. So let's grab the inbox. Let's copy to 12, just because we have that already. Get rid of that. Copy from the number of there and go to the outbox and jump to the beginning of the program, and that should be it. 9, copy from that position, grab the next number, copy from that position, output, where do we have speed, there we go. This was too easy, let's do one more level. Storage floor 29. Hopefully I get it, by the way. 25 steps, yeah. There's nothing to... there's no way to lose that. String storage floor. Special code assignment. Management is requesting strings from the floor. Let's just process the strings and not read or discuss what they say. It would be impolite to read messages intended for someone else, and forbidden. Each thing in the inbox is an address of a tile on the floor. Yes. For each address provided in the inbox, outbox the requested item from the floor and all following items on the floor until you reach 0. Repeat. What? Oh, and all following. Okay. So that means I should bump it, I guess. Inbox. Drop it to 24. Copy from the position of 24. And go to the outbox with it. And then bump 24. And make a loop around this. But when I copy from... oh yeah, we bump that into the next. But when we copy from 24, if it's a 0, we should return to start. Yeah, this should work. Or let's grab that, go there, 5, grab that, put it on the belt, increase that, and grab that 0. If it's 0, let's get rid of it. Hopefully this works. Might be that it doesn't. Okay. It might be that they wanted the 0 as well on the belt, but apparently not. This should just work. And this is actually not bad at all. I mean, there is another way of doing this, the cheaty way. That is to fill up everything with zeros. And then just put things on the 24th line. Technically, it would be correct, but I don't think they would like it. Yeah, continue to the elevator. Let's go the string reverse as well, just because we can. Olle. Jadot oi eravo. Haha. Haha, okay, no, seriously. For each zero terminated string in the inbox, reverse it and put the result in the outbox. Repeat. Okay. First thing I want to do... Actually, I was thinking about I need to preserve this zero, but I don't need to. I will pick up another one. I need to preserve this zero. Copy from that position, copy to that position. The reason I need to do that is to... Don't need that. Don't think so. Okay, let's do a loop. Go from the inbox and copy to whatever that number is. And once you have done that, bump plus that number. Okay. We have the exception if this is a zero terminated string. So if this is 0, we jump to after that, and we want to output everything. And we haven't copied it, we haven't bumped it, which means we should, I think we should bump minus that one, copy from the position of that one and to the outbox, and then do that over and over again. And we should do that until this number is negative. If it's negative, we start over. I think this will work. Put it at the 0 position, increase that. This is the 1 position, increase that. Oh, or will that cause problems with this? Put over there. We will put over there. Oh, yeah, I did miss one thing. 0, get there, and then it will decrease it, and then, yeah, I didn't think about that. We will get to -1 where it tries to place the digit. So, if this is negative, we actually want to go to the end, bump plus that, and then go to the start. Get rid of that negative number, get it positive again. This is because we have the bump positive and bump negative. If we didn't have that, it would be way easier to do, but never mind. String root. 11 command, 12 commands, okay. And one step. Let's try to fix that. One command. I mean, I could move this up, and this would be pointing above, but then I needed the jump to be from above to after this bump, so that wouldn't solve anything. And this jump if 0, it's the number we grab. Oh yeah, also if I do copy this to another space, this wouldn't be bump plus, that would be copy from that to that, which is 2 commands instead of 1, so that wouldn't help. Oh, now I know. Now I actually think I know how to fix the amount of commands. Instead of jump if negative, let's go jump if 0. Go down here, remove that. Don't bump that, just copy from 0 box and place it in the outbox. That should solve the number of commands. Since we have one command less, we don't decrease this anymore. We do the same amount of jumps and everything else, but it will definitely not solve the size of the program. That's 13 now. Yes. This should be right on the... Oh! That's way better than I thought. But let's go for the size challenge as well. How can we solve that? I mean, this is what we had before. I have a problem seeing how we could minimize the amount of rows. Unless... if we place this whole block with the output before the inbox, would that solve anything? We do have this that jumps forward. We wouldn't need this, but we would need one command that jumps, that skips all of that. So I don't think that would solve anything. Oh, and this one would jump back? Well, maybe it would. Let's see what happens. Let's just put a label. One label there, one label here, to know that everything below this label should be put just above this label, in the same order they are right now. That way we don't have to worry about actually reading the code and understanding it. We do need to double check it, of course. Yeah, jump to the same row. That doesn't really make sense. Okay, jump if 0. We should jump to output everything. Let's get rid of those commands. This we don't need. We do need jump to start. Go to the inbox. If it's 0, we want to output. Otherwise, we go through this. 0, we go here. We decrease. If it's 0 here, no. If it's negative here. We bump that. Copy from. I don't think this have done anything more than make the code harder to understand. Somehow it made a difference. I don't really understand how, but okay. I need to pause for just 1 minute. Just spilled some water, have to fix that. And I'm back. Why are we still in this level? Let's run it through it quickly once more. Just for the fun of it, let's do the next level as well. And then let's end it. $121, yeah. I don't really understand this. But never mind, we got all of it. We did. Why didn't you add both of those? Okay. We need to do this jump 0. Remove the jump is negative. Hello again, tell me more, give me an example. Optimization challenges. No, I didn't even know you could click him. Or click me, I guess. No, it's not me. This guy have gray hair, I have black hair. But yeah, if 0, copy from number 0 box to the out box. Let's remove that, run through it, and that should be the least amount of steps. Get the second point. I don't know why it didn't save that. This is the size challenge. Wait, what? You best used 12 commands, but I did use 10, I think. Let's go back and let's actually fix this. once and for all. Let's do the same we did before, with just moving things around. This... Oh yeah, this should actually be for the inbox. Yeah, so I think all we should do here is basically copy everything down and then we fix any problems. Which we seem to have a few of. 2 jump commands that jumps to the same place doesn't really do anything good. Okay, so get the inbox. If it's 0, we want to output, otherwise we look through the inbox, place it and bump the place we placed it in. If we do the outbox, we want to decrease the amount of... Wait. I have an idea that might solve all of our problems. Instead of first copy to and then bump, let's actually first bump it, then inbox, then jump if 0, then copy to. And do that to read everything. And when we have a 0, we want to output. Then we don't need to remove a number to start with. We basically copy from the same place we placed it in before we go to the outbox. Then we decrease. Oh, no. Then we decrease this one, not the reference of it, but the actual number of it. And then we go to the start. And if that is 0, we go to the outbox. No, we don't. We don't need to go to the outbox. We already have everything placed, so if it's 0, we have already placed the number 1. We want to go to the start. Let's see if it works. It should. It should work, and it should actually solve both of the problems. The only issue is that we are not using the 0 position, but I think that's kind of okay. Oh, it will still increase that. So we still need to decrease that to start. Let's see what happens if we decrease it first. It might very well be that this doesn't work, that we actually should add a negative bump in between to decrease it once before we do anything. And then we are back to the same thing we have had all along. Don't jump. Jump. 0. Empty hands. Wait, where? Oh, yeah. We need to place that there. We need to... Do we? If we place it there, and then we check if 0... That should kind of work. Yep, this seems to work. And this is definitely fewer commands than I had before with decent code. Oh, but we do get the bump no matter what. Which means we get one extra step. But that worked, so continue to elevate now. Finally we got both of them. Since we have only one left until the next coffee break, let's do this one. Inventory check. Accounting verification. Surprise audit. These are a few of my favorite things. So let's get started. For each thing in the inbox, send to the outbox the total number of matching items on the floor. Okay. This one is tricky. So basically we want to check what we have here against all of the numbers in order. To do that, I think the first thing we do is to grab the inbox and copy it to space 18. We copy from space 19 and no. Copy from space 14, get 0, and we copy that to space 19. Okay, so now we have 0 here, we have whatever we have there, the letter, and we do a loop where we do wait, how can we check that? Inbox, outbox, that's fine. Copy from, copy to, add, sub, bump, plus, bump, minus, jump, jump if 0, jump is if negative. We don't have any commands to be able to check if this is the same that's in this box. I think. Let's just for testing, go to inbox, add 2, because I know it's the same, and I think that will break. Can't add with that, what would that even mean? I know, I can't. That's what I'm trying to say. Oh, it's possible to have several programs. Didn't know about that. Can't add. Inbox, outbox, copy from, copy to, add. We can't add, we can't subtract. I mean, there is a way to do it. No, there is. Technically, there is. Could calculate all of this manually? No. And then output 1, 2, 3. Output a 4, 3, 2, and 5, or whatever it is. That technically works, but that's not in the spirit of the game, so I'm not gonna do that. Each thing in the inbox send to the outbox the total number of matching items on the floor. Tell me more. How can you determine if two letters are equal? Maybe try the same thing you would do if they were numbers. Mean subtract? Yes, B is just one more than A. You've made it this far. I'm sure you already knew that. But I tried to add and that didn't work. So please don't tell me that subtract works. That add shouldn't work and subtract should work? That doesn't make sense. That's 0. Okay, and that's something else. That's something else. This is I'm sorry to say, but this is messed up. This is totally messed up. But okay, now we have placed the digit, we have the count, we have count, we have digit, or actually no, we have letter, not the digit. Letter, copy from 14, copy that. We want to copy from letter, subtract oh, we need another space. This is the new letter. Come on. An L, is that so hard? This is the that's the letter. Copy. This is incrementer, and this is the count. So copy to letter. Copy from 14, copy to count, and copy to increment. So we are starting from letter 0, 0. Copy from letter, subtract the value increment, if 0, if 0, jump plus countdown, then jump back. This is not a nice way of doing it, but never mind. And whatever we do, bump the incrementer. Okay. Copy from L. No. We shouldn't copy from L. We should copy from the increment, the value of the incrementer, and then subtract L. The reason to do that is that we want to terminate at 0. So we can check if 0 when we copy. We want to take the count, copy from count to the outbox, and then start over. Same, let's increase the count. Okay, this seems to be working. There's a lot of things that needs to be done. have a look when we get to the last one. We go 5, 14 to 0. Let's copy the count and put that there. Oh yeah, and then we reset everything and we start on it. I'm sorry to say, but this is the dumbest thing ever. Subtracting letters when you can't add them, that doesn't make any sense. Doesn't make any sense whatsoever. Okay, we made the size but not the speed. Let's go to the elevator this time. Save the size and let's go back and do the speed. Oh yeah. No, I remember. This is why we move it up. If we move up this 0, copy to the top, we don't save any commands, but we don't loop through and do 2 jumps for everyone. We do 1 jump and then so 1 jump for each of the 4. Right now we do 1 jump to get down, 1 jump to get up to the start. If we move it to the top, we do 1 jump, get to the top. For each of them, that's 4, plus 1 in the very beginning. So let's actually do that. I'm not sure if this will solve anything. Oh, should have kept that jump, but never mind. See if that solves anything. It takes quite a while for this to finish. And 13, 14, and it's done. Let's see if we got this, well, the size we did. Oh, we did, but the speed. 401. We still don't have it. That's fine. Don't like all of the jumps we have over here. This jump. I don't think we can get rid of that. Copy from... Wait one second. Oh, okay. So this is... If it's the same number, we want to bump the count. Then we go back. What if we move these down instead? So we don't go back. Instead, if it's 0, we do the count. Otherwise we jump directly to the iterator and then jump back. Maybe that solves something. I mean, there is possibly one way of minimizing a little bit, and that is to first copy the 14 into incrementer and counter. And then worry about the letter. Oh! Okay. That was not a good idea. Let's revert this if we can. If it's 0, we want to increase C and then go back to bump the incrementer and do the next round. Yeah. Let's just check that this is actually what we want to do. Because I'm not sure. And then we can try to move these around if it's just a few steps that's missing. But I don't think it will really help. Might make a difference of a couple, maybe 3. But that's guesswork. $401. Yeah, we're back. Please. Let's see what happens if we move these to the top. And then... Oh, but we are not copying from the letter. We are copying from that, so that doesn't work. That would result in more commands. Oh, wait. No, we can only hold one value in memory. I was thinking about moving this over here. But we always want to... Wait, can't we do that? Getting rid of a lot of jumps. I actually think we could do that. But we start with dumping it. If we bump it, the first thing we do, then we don't need this jump to go back to another jump. We can jump directly up here. Yes. But bumping it directly will mean we will never see the 0. So copy to incrementer and bump minus the incrementer once in the store. Now it should work. And we do have one command more, I think, than we had before. So we won't get the size, but the amount of steps we should get. Yeah, we save one jump every time we have a match, but we do pay with one bump on every letter in the inbox. One more command, that's fine. 600. 2 commands or 2 steps too much. Oh, we do bump minus and then bump plus. And we do that 4 times. What if we, instead of doing that, from here we jump to after the bump plus. We remove that completely. So we have it to 0 at this point. Then we go through it and then we start increasing by going back before the bump. Yeah. Now we should get like 1 or 2 fewer than the limit. The problem with this level is that it takes quite some time to go through it, or if you really have to debug it, that would be really, really annoying. I think we will still get 17 in the size, because we removed 1 bump minus and replaced it with a loop. Yes. Continue to elevator. And we got all of that. So let's check. Where's Carol?
Hey, where's Carol? Oh my god. This comes amazing. What's up, ladies?
What's time?
Breaking. Previous reports of machine army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
Somehow I don't think we're gonna be fine. But yeah, that's another thing. I want to fix this, but let's not do it today. I spent like an hour on it. But yeah, I think that's it for today. And next time we will maybe look at that again. Maybe finish it, maybe get just a few more levels in. Anyway, we'll have to see. Thank you so much for watching, and I'll see you next time. Bye!